talking about simultaneous equations, you just missed my visual of how we find out, or the three situations that can happen. We can have here where they intersect once, and we call this a unique solution, one point of intersection. You don't need to copy this down unless you want to. We can have where they are parallel. Remind me, how do we indicate that lines are parallel? They're same slope, but how do we indicate it on our diagram? The little arrows, correct, right? Parallel. And I will even put that there, i.e. same slope. And what happens here is you get no solution because they will not meet ever. And that's what we're actually trying to find out over here. And then, of course, we have the last thing. I don't know what's happened with my frame here. Anyway, we have the last one where we have one line on top of the other, and that's what we call coincident. Okay. Coincident. And we would have infinitely many. I can hear people madly write, but you don't need to write this down if you sort of understand it. If you want to, by all means, go forth. There are three methods. The first one is graphically. It means that we actually have to draw. We have to draw the two graphs. And if we want to find out where they intersect, it means we have to do it really carefully, not a sketch, an actual draw to scale. That involves, you know, specific 2 points, getting it really beautiful. We don't like that method. So we'll show it to you, but we'll go, probably not. We're then going to look at today, in 10 minutes, I'm hoping, substitution. And then we've got elimination. So those are the three. We're going to focus on substitution, elimination, because they're the algebra type ones. Okay? So I guess we're going to start with our friend substitution. And if you're going, why do we need all these different methods? You'll see in a minute it's about how the information is presented to you, and you will automatically go, oh yeah, this is the one I'm going to do. You'll flick between both. Don't trust me yet. Trust me when you have done both methods. Jeez, what did I do? Okay, so put example, and you don't need to write all the words. We're just going to write these two equations, and when you're ready I will know, because I can see your beautiful face. So if we were just looking at one of these lines, we've got infinitely many solutions. When x is 1, what would y be? 6. When x is 2, what would y be? 7, etc. What we want is we want whatever value for x we put in here, we would get the same value for y that we put in the second one. Guessing is going to be all day. So we're going to do exactly what it's telling us to do. Substitution. What does substitution mean? Swapping numbers. Another word for substitute. Replace. I like that word, replace. And so that's what we're going to do. See here how it's got a nice y equals this? Yeah? What do you think we're going to do? Correct. Where we see y here, we're actually just going to replace it, aka substitute. So we've got our eyes focused on this, and we're saying, right, we're going to write the 3x. What comes next? Take. I put take, but I'm not taking y. I'm taking, because that is y. I'm careful here, because I'm going to make sure I use my bracket. So I've done this. What comes next? Equals 1. Now, Hamish, you're entitled to go, well, hang on, this looks much worse than those little equations that we had there. But how many unknowns have we got in that one line, Twigs? Just x. Just one unknown, and we should be able to solve this beautifully. Do we agree? We've got the 3x. Can't do much with that. But I'm now taking x. I'm taking the 5 equals 1. And now we're going to rock the ouch. Rock the ouch. Rock the ouch. 2x, thank you. 2x. Get rid of the take 5. Plus 5. Oops. I was writing what you said instead of paying attention. So equals 1 plus 5 is 6. You could solve it at this point. It's saying 2 times something equals 6. X is 3. Wait. Now you're not done, because what we want is we want to find at what point, so we've got 2 lines here, at what point did they meet? So that means we've got our x coordinate is 3. How do we find our y coordinate? Sub in. Which one do you sub into? I would. Can that be the only one you sub into? It could be either, but obviously the top one is so nice. It's saying y equals x plus 5. You're telling me that x is 3, so therefore y is? Yep. I'm going to write it here, just if you want to go back and look at your example. 3 plus 5, so you get 8, and therefore it's going to intersect at 3, 8. How nice was that? Okay, so we've got edit, we're going to paste, and here we go. Let's fill yellow. Dark yellow. Okay, so again, solve simultaneously. This is under the section of substitution. And so nicely, we've got again y equals. So that's what we focus on. And we're going to sub that into the other equation. Happy with that? So we're going to start with this equation. Underneath we write 2x plus 3, but instead of 3y, what is y? Yep, and the only way you can stuff it up is not have the brackets there. So x, take 3, then back to this, equals 26. Please digest that, look, understand why we've done that, because after that it's just algebra and we're all good with that. But that is the bit. I'm seeing some of you actually finish this, not waiting for me, so well done. So expand our brackets. Do be careful. You've done a lot of other algebra. Don't forget, positive times a negative. Negative. 3 3s are 9. Gather our like terms. 2x plus 3x. 5x. 35. We happy now? Fancy it up a bit. Put your little therefore. X is. And Ella, I know you're listening to us at home, and Jessie, we want the y value. So Aiden, how do we do that? Correct. 7, take 3, 4. So we end up with 7, 4. Remember, maths is all about, yes, not just doing it once. You have to make sure that you understand, and then you can do it swiftly, and you're good at this. So question 1 and question 2. Right, maybe if you want to skip 2 of them, you can, but at least maybe do 4 of each. Same with 3, you know, oopsies, now we've got fractions in there. The same thing will apply. It's not a big deal, but have a go. Again, maybe just do 3 of those. And yes, you can work your way through, okay? They don't take a long time. We haven't actually done 4, 5, and 6, but we talked about the fact that sometimes they might not intersect. And so maybe, do you think they might be asking you about parallel stuff happening? So think about it. Yes, dear?
Are you going to teach us how to solve it graphically and by elimination?
Yes, I will be doing graphically and elimination, but if you finished your worksheet, then I'll come and help you with that stuff. But I was hoping to do elimination today, but that might be tomorrow, depending on how people go. Play it by ear. Is that okay? Coming? Was it about this?
Yeah.
Yeah?
Does the curly bracket mean solve simultaneously?
Yeah, it's just saying they're a pair. So the question was, what does this curly bracket mean? It's just saying that they're together, they're a pair. But I've just cut this. So this is D coming under question 1. So it's still all under the solve simultaneously. So can leave it on the board. I've just picked these because sometimes when students are doing it, it's like, oh, how do we go? Well, same deal. We've got y equals this. We're going to sub it in place. So it's like, well, if y equals this and y equals this, they equal each other. So 2x, take 12, equals 13, take 3x. How do we solve? Get your x's on one side, non-x's on the other, and solve. Do we agree? I'm not going to do that for you. I think you can manage that. And what's the big deal with question 2? Ooh, question 2. It's not the y equals, it's the x equals. Correct. So, yep, exactly. So you just solve the x in place of, you guessed it, the x. So this would now be 5. Instead of 5 times x, what is x? Y plus 9 plus 2y equals 10. I don't know what happened with my bracket there. That looks a bit funky. And expand the brackets, solve for y, don't forget to find x. Yes? Does that seem reasonable? So, please, if you wanted to just spend a few minutes going, I'm going to get this under control, I want to do some, make sure my examples are nice and neat, then I will go to the worksheet, by all means. If you want to go to the worksheet first and then do this, by all means. Let's see and chat again in half an hour. Good? Okay. Someone's writing you a message, but they don't want to say anything. Who do you think it is? They're going to say one word to you. One word. Say your pet's name. No, just shaking her head, doesn't want to do it. Anyway, let's see if you can guess who wrote that message to you. Let us know. Jessie? Is this the same mystery person or is this a different mystery person who's writing you a message? You have to tell. Taking a very long time. So people are handing up their worksheets preferably tomorrow. Some are doing it now. That's fine. So email me, guys, if you are stuck. And, yep, we missed you guys. Oh, they're still writing. Got to pause it.